This Arduino-based room temperature warning sensors with buzzers and LEDs is designed to serve as an indoor passive thermometers. These temperature warning sensors may be placed in any corners of your home to monitor changes in the ambient temperatures. The temperature sensors in these systems will detect any changes in the room temperatures. The buzzer and the LED will trigger if the temperature is lower or greater than the specific optimal temperature. It might be beneficial for families with sick or elderly who want to avoid creating discomfort due to heat. And next, the project scopes would be restricted to its intended use at home. The indoor temperature monitoring systems would detect to understand it of the temperature sensors output voltage and how to implement them. The formulas on how to convert analog values to scala in degrees Celsius, the programming of the microcontroller, understand the working principle of the each electrical components, applications of the software such as the LabVIEW, Arduino IDE, and the Tinkercad.
Good day and salam sejahtera to Madam Nabila. My name is Kartik Raj Analaki Nityanandam, ID number FA20041. Today I would like to introduce about our project, which is temperature sensor. And first of all, I would like to explain you all and Madam about monitoring system. What is monitoring system? It is an automated system that continually monitors one or more physical parameters such as temperature, relative humidity, wind speed, light intensity, soil moisturizer, and so on. Monitoring a sensitive area on a regular basis can help fulfill health and compliance requirements. We can use the data from the monitoring system in conjunction with enhanced service life prediction models to save money on the life cycle. As a solution for this project, we wanted to introduce the ideas of virtual instruments, LabVIEW, data gathering hardware, and specific sensor. We also use a LabVIEW to create a program that record analysis temperature data from an ambient sensor. USB and the Arduino board were used to implement the data collecting method. Digital Links add-on was also introduced in this project. Links is freely available in LabVIEW add-on that includes VIs for communicating with common platforms such as Arduino, Raspberry Pi, and other system. Use the built-in sensor VIs to receive signal and transfer it to your PC in seconds, or use the external VIs to connect your device digital I/O, analog I/O, SPI, I2C, UART, PWM, and other function. That's all from me. Thank you.
Hello, my name is Muhammad BFF3313. My ID number is FB19055. I will continue the presentation about the methodology. It's for the list of required equipment and software. For the list of equipment, we are using Arduino Uno Rev3 and temperature sensor LM35, buzzer, 3 LED, resistor, capacitor, and few other circuit items. So for our total cost will become 123 ringgit. For the software, we are using Tinkercad and LabVIEW. Tinkercad will be used to the pre-designed electronic circuit and simulation, while LabVIEW will be using to build block diagram and GUI panel. For the component characteristic for LM35, LM35 are accurate temperature sensor device having a linearly proportional output voltage to the temperature in degrees Celsius. That means LM35 able to produce a reading by sending an output voltage and change it to the degree Celsius reading. And this is the specification for LM35. Next, we are having an Arduino Uno. The Arduino Uno is a microcontroller board that utilizes at ATmega 328P microcontroller. It's incorporated into a variety of different electrical projects. Arduino Uno is a very widely used PC-based item, and this is the specification for the Arduino Uno. For the LED, LED is a two-pin semiconductor that produces light when triggered. When a suitable voltage given to the LED terminal, the electrons within the device are able to interact. This will produce a photon. This effect is defined as electroluminescence. Energy absorption coefficient of the semiconductor determine the color of the LED. We are using three different color LED, yellow, red, and green. And this is the specification for the LED device. For the buzzer, buzzer is an effective component that can be used to bring sound to our project or system. Small and contain two-pin shape allow to utilize on the breadboard. And this is the buzzer specification. We are using buzzer because it's small and neat seal package, breadboard and board friendly. And that's all from me. Thank you.
A very good day. My name is Long Yibing and my ID number is FB19054. Now I'm going to talk about the circuit diagram and the analysis. Here is our circuit diagrams. The Arduino Uno connected with a breadboard with buzzer, 3 LED lights, and 4 resistors and LM35 and 1 capacitor. And next, here is our schematic circuit diagrams. And next, we can see how does it works with the Arduino Uno connected with the computer with the lab view. I will include a video to show how does it works. After watching the video about how our temperature sensor works, and here I'm going to showing to you how our GUI front panel looks like. And next is our block diagrams to control and to build the GUI front panels. As the Arduino connected to LabVIEW software via USB, the data was collected from temperature sensor and displayed on the GUI front panel. The temperature data will display in various forms on the front panel, including numerical data, thermometer bar, and the wavefront chart reading. And next, here's our thermometer bar display looks like and wavefront chart display. Besides, the status of the LED and the buzzer also can observe on the GUI front panel. When the LED or the buzzer were switched on, the LED indicator on the front panel will also be triggered. Moreover, the GUI front panels also provide a feature to self-define the threshold of the temperature value. The temperature sensor LM35 is supplied with 5 volt of the DC power source from the Arduino Uno. As the power supply was provided, the LM35 will measure the surrounding temperature. The output voltage across the diode will increase proportionally to the temperature value as the temperature increases. The temperature values will simultaneously display on the GUI front panel. By applying the condition statements, when the temperature value is beyond the threshold, it will trigger the activation of the components such as the LEDs and the buzzer. Through this table, we can see that when the temperature is below than 30 degrees Celsius, only the green LED is on. When the temperature is between the 30 degrees Celsius and the 34 degrees Celsius, only the greens and the yellow LED is on. When the temperature is over than 34 degrees Celsius, all will be on, such as the green LED, yellow LED, red LED, and the buzzer is on. Now, I'm going to talk about the procedure. Firstly, all the components and equipment list were prepared before connecting the circuits. The circuit was designed according to the arrangements using the software like Tinkercad. After confirming the circuit configurations, connect the circuits according to the arrangements on the actual components. Connect the VCC pin, pin 1 and the ground pin, pin 3 of the temperature sensor LM35 respectively to the 5 volt pins and the ground pins of the Arduino Uno. The maximum and the minimum input voltage of the LM35 is 35 watts and negative 2 watt respectively, while 5 volt is the typical value of the various applications. Therefore, the voltage source of the 5 volt is acceptable. Connect output pin 2 of the LM35 to analog pin A0 of the Arduino Uno for analog data collection purpose. Connect capacitors in between the VCC and the ground pins of the LM35. This is the purpose of the noise filtering in temperature outputs. Connect the resistors in between the outputs and the ground pins of the LM35. This is the purpose for minimize the problems of LM35 self-heating error. And next, connect the green, yellow, red LED respectively in the parallel circuit. Next, connect the positive pins of the buzzers to the digital pin, D11s of the Arduino Uno for transferring digital signals, while the negative pin connected to VCC. Connect Arduino Uno to PC via USB cable. By using the LabVIEW software, build the block diagrams configurations interact LabVIEW software with the Arduino platform using the Lines, Maker Hubs, Atom tools. Ensure to install all the requirements for the LabVIEW Arduino interface, for example, LabVIEW, NI Visa drivers, JKI package managers, Digilance links add-ons, Arduino Uno, Arduino IDE. Next, I will show you how we build the block diagrams. Firstly, ensure to install all the requirements of the LabVIEW to Arduino interface functions. Insert open block and close block into the diagrams. Connect the analog reads blocks to the open.vi blocks. And after that, after reading the analog signal, transfer the signal to the temperature sensor like temperatures 35 blocks. And next, connect and if statement program using the configuration of the temperature C variables for loops, logic gates, Boolean constants, and more. For conditions when the temperature is less than the bottom threshold, compare whether the temperature value is less than the controllable constants. If it's true, the values will enter the for loops with condition true. The Boolean configuration of the LED will be true only for the green lights, while false for the others. If it false, the value will enter for the loops with the condition false. In the false conditions, the temperature value will be again compared to whether it is greater or equal to the upper threshold. If it is true, the values will enter another for loop with the condition true. The Boolean configuration of the LEDs will be true for all LEDs. If it is false, the value enter the for loops with the condition false. The Boolean configuration of the LED will be truly only for greens and the yellow LEDs, while the false for the red LED and the buzzer LED indicator. Connect each Boolean constant with digital write blocks to control the actual components on the Arduino circuits. Assign the digital channels to the pin that is used in your Arduino Uno boards to write digital data and control the components. For this case, is digital pin 8, 9, 10, 11 respectively for green, yellow, red LED and buzzer. Lastly, connect all lines resource ports and error ports in a series to open and close blocks outside the while loops. Assign the delay blocks for 500 milliseconds for better data collections. And that's all from me, and thank you.
Hi, I am Lingeswaran Aplasami and my MATI number is FA20024. Here I would like to talk about the conclusion. In conclusion, the ability to activate indicator component like as LEDs or buzzers is done effectively. And the main purpose of the design is monitor the temperature change of the surrounding. The temperature monitor is a difficult task that necessitated low cost solution. The temperature monitoring system show how to get temperature measurements using the microcontroller and display them on a user-friendly graphic using interface. On the front panel, the user may set a set point temperature value. The Arduino Uno does not have the functionality to connect to Wi-Fi and establish an IoT system, which make the realistic. The principle of this system, on the other hand, may be expanded to construct unique data collection and control device for both network and standalone application. Thank you.